So today is an optional lesson for you guys, but it is important. So if you're able to at least just watch this video, I'll be happy. Beyond measures of central tendency, we also look at something called a variation within a data set. Last year in 7th grade, we did look at variation a little tiny bit. We looked at it in terms of the range, and we also looked at the interquartile range, which is when we take the upper quartile and the lower quartile and we find the difference between them. We also found the, what did we find? The mean, I forget. I think we did the mean absolute deviation. Yeah, that's what we did. So we found out how much each value in the data set varied away from the mean. What we're going to do now is we are going to learn how to use our calculators to find something called the standard deviation, which is similar to the mean absolute deviation. But before we do that, let's talk about the beginning here. Measures of central tendency give us numbers that describe the typical data value in a set, but they don't let us know how much variation there is in the data set. So like we saw yesterday when we found our mean and our median, sometimes the outlier affected the mean a lot, and the median was a better representation. In that case, there was a lot of variation from the mean. You know, for example, we had those test grades from that calculus test, and there was a 45, right? It brought that mean so much down. There's a lot of variation there because the highest grade was like a 95, and then we had that 45. Something that you can't see just from looking at the mean. So two data sets can have the same mean, but they can look radically different depending on how varied the numbers are in the set. So for exercise 1, we're looking at these two data sets. They each have equal means, but they differ in the variation within the set. So what we're going to do is we're going to find the interquartile range of each data set. Okay, so we're finding the quartile 1 and quartile 2. So I'm going to show you something really cool. In your calculators, you can enter data sets in, and you can look at the statistics for that data set. So this would be data set 1, okay? What we're going to do is we're going to use the stat button, and that's here. So you're going to go to stat and then edit. So you just push enter, and it's going to give you spots to put lists in. So where it says list, you're going to put in your data set, okay? If you have numbers in here, in order to clear it out, you have to go up to the L1 and then push clear. Otherwise, it's not going to work out for you. So I'm going to enter each data value in here. So I have 3, and I push the down button, 3. I have 2 4s. I have 2 5s, 2 6s, a 7, 2 8s, 2 9s, 2 10s, and 2 11s. Okay, so that's my data all in there. Just trying to make sure I didn't make any mistakes because I wasn't looking as I did it. So I was looking at the calculator. Okay. And once you have all your data, what you're going to do is you're going to go back to stat. And now you're going to go over to calc using the arrow. And we have one var statistics. That means one var stats, that means one variable statistics. So you're just going to push enter, and it's going to give you this screen, or if you have one of the newer calculators, once you push enter there, it'll automatically go. But if not, it gives you an option to select list 1, because sometimes you'll have more than one list there, and you might want to calculate one of the lists alone, or list 2 or list 3. So this gives you the chance to say what list you want. So I'm just going to push enter for calculate, and enter. And now what I have here are a whole bunch of statistics. This X bar is my mean. Okay? If I scroll down, I can see other values. Okay, my minimum. And then here comes my quartiles. So instead of me having to calculate it, if I just scroll down a little bit, I can see my minimum values here, my maximum values here, and my 2 quartiles are here, even my median. So you can actually get all of the data from here. So x bar, I'm just going to put on the side here. X bar means the mean, okay? Q1 is 4.5, so I'm going to write it here. And Q3 was 9.5. So x bar in this case, which is our mean, was 7. Okay, now to find the interquartile range, I now have my data, so I'm going to clear out here. Your interquartile range, remember, is when you take your upper quartile, or Q3, and you subtract your lower quartile, Q1. So 9.5 minus 4.5. So the interquartile range for the first set of data is 5, exactly 5. Okay? Now, we're going to take a look at this second data set. And we're going to put that in here, stat, edit. Now you can choose to go over to list 2 and do that, or you can go up here, up to L1 and push clear and restart, okay? In order for that to really clear, you have to push your arrow down, okay? And then it'll all go away. So now we're gonna enter this in. We have 2 5s, we have 2 6s, 2 7s, 2 8s, and 2 9s. Stat, calc, enter for one var stats. List 1 is good, so enter, enter, enter. 1, 2, 3. And here we go. As we were told, the mean is the same. So the mean for the second data set is exactly the same as the first one. But now let's check out our interquartile range. Our median is also 7, just like the other one. And my Q1 is 6. My lower quartile is 6, and my upper quartile is 8. So when I find my IQR, my interquartile range, remember I'm doing upper minus lower. So I'm doing 8 minus 6, which is only 2. So here's the difference. Even though these two data sets have the exact same mean, this one has way more variability. The difference between the upper and lower quartile is 5, and here it's only 2. When you look at the data, you can see why. The lowest value here is 5, the highest value is 9. They're all very close together. In this case, the lowest value is 3 and the highest one's 11. So there is more range here. There's also more values, right? So the interquartile range gives us a good measure of how spread out the data is. But the best measure of variation within a data set is called the standard deviation. Dun, dun, dun. The actual calculation of standard deviation is complex, and we're not going to go over it here. If you guys take AP Stats or AP Statistics in high school, you will learn how to do it there. If you take statistics in college, you'll learn how to do it there as well. But we're going to use our calculators for this. And we're going to do the exact same thing. I should have kept that data set in because I just realized I needed to use it. So to find the standard deviation, you do the same thing, but this time you're going to look for this symbol. Okay, that is the symbol for standard deviation. Okay, so it's here too. That's the one we're looking for, okay? So for data set 1, we're going to find that, and for data set 2, I already have data set 2 up here. So I'm going to go back here, and I'm going to look for it. Here it is. This one is my standard deviation right here. Okay? So we're going to go like this, and it's equal to 1.41 blah, 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 blah. They said nearest 10th, so we're going to round to 1.4 for data set 2. Now I'm going to go back into stat, edit, and I'm going to clear this out again. I'm a little mad at myself that I forgot we needed that. Please note, when I push clear, it does not go away. You have to get out of the box in order to see it disappear. So I'm going to re-enter all this nonsense here. So we had 2 3s, 2 4s, 2 5s, 2 6s, 1 7, 2 8s, 2 9s, 2 10s, and 2 11s. Okay, stat calc. enter, enter, enter. And our standard deviation is right here, 2.65. So that's going to round to 2.7 when we do the nearest tenth. Okay, notice you don't include the x when we write this because the x is a variable standing for the set that you're using. So when you write standard deviation, you just use this little symbol here. So when there is a greater standard deviation, that's telling you that typically the data is varying this much. So a higher standard deviation implies that there's more variation. Okay? So what it really tells us is, on average, how far a data point is away from the mean of the data set. So like I just said, the larger the standard deviation, the greater the variation is within the set. So on average, these data points are about 2.7 away from the mean, which is 7. But in this data set, they're only 1.4 away from the mean, which was 7. Okay? So, let's see, what else did I want to do? Let's do number 3, okay? So we're going to find, using our calculators, the mean, which remember is x bar, the interquartile range, which is Q3 minus Q1, okay, and then the standard deviation, okay, which looks like this, okay? So you guys can pause and enter these in to your calculator, find these values, and then unpause and check. Okay, so hopefully using the calculator made this much easier for you. Going to stat edit, putting in your list, and then stat calc, enter, 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 and then x bar, which is your mean, is given here. So it's 3.7 ounces. So the average weight of one of these baby chicks is 3.7 ounces. The interquartile range you find from here, getting the Q3 minus Q1, which is 2.5 ounces, and the standard deviation is 1.7 ounces, which means that all of this data on average varies from the mean by about 1.7 ounces. Okay, so for exercise 4, we're looking at a marketing company that's trying to determine how much diversity there is in the age of people who drink different soft drinks. So what they do is they take a sample of people and they ask them which soda they prefer. So for the 2 sodas, the age of the people who preferred them is given below. So for the first soda, this is the ages of the people who liked soda A. And soda B, these were the ages of the people that liked soda B. So first, we want to say, why is the standard deviation a better measure of the diversity in age than the mean? Well, that's because the mean is just going to give us the average age, and diversity means we want to know how much different they are. So standard deviation is better because it's going to show the variety of ages. Okay. Okay, so if we find an average, it's not really going to show us how much these ages vary. Finding the standard deviation will show us that. So we're going to decide which soda appears to have greater diversity in the age of the people who prefer it and how we decided. So I'm going to have you guys do this on your calculators again to try it out on your own. And then you can unpause and check your answers against mine. You can put both lists in at the same time if you want. And then when you calculate it, just make sure you change list 1 to list 2. For part C, they want you to also find the sample standard deviation. You don't have to do anything new here. You're just going to look for SX instead of, this is the population standard deviation. And SX is a sample standard deviation, which means that that's coming from a sample, okay? So I want you to do this in your calculators, and then you can try this one as well and see what happens. Okay, then unpause and check against mine. Okay, guys, so for part B, which soda appears to have a greater diversity in the age of people who prefer it, without showing any calculations, you can say that soda A appears to have more diversity because it ranges from a low of 16 to 40, and soda B ranges from only 18 to 30. Now, I also included the calculations because I was not sure if some of you were going to do that in the calculator. If you found the regular standard deviation, A would be 8.8 and B would be 3.9. However, because this was asking for a sample, what we were asked to find was the sample standard deviation, which is usually very, very close to the regular standard deviation. But if you're asked to find the sample standard deviation, you have to make sure you do that, and we're going to talk about why in a second. But you look for the SX instead of the regular standard deviation. You're looking for the S. Okay, so in there, what you find is that soda A is 9.1, soda B is 4.1. I will just quickly show you because I still have it in my calculator. You go to calc. Oh, by the way, if you weren't sure how to change from list 1 to list 2, they are using the second button. So you go, let's say if I want to go back to list 1, you push second, and then list 1 is 1, and it gives you list 1. Okay, if you want to do list 2, you go back here and you do second 2 for list 2, and it changes it for you. Okay, and then just enter, enter, enter. And as you can see, the regular standard deviation is here. The sample standard deviation is here. So that would round to 4.1. Okay, so what is the difference between these two? So if we're working with every single possible data point of interest, we call that a population. And we use the population standard deviation, which is given with this symbol. When we only have a sample of all the possible values, we use the sample standard deviation, which is S. There's a slight difference in the formulas, so their values are a little tiny bit different, but they're usually very, very close to the same. Okay, this is something you're going to talk way more about in if you're in an AP class or in college. But most of the data that we get is a sample. Okay, if you're choosing your population to be your class and you ask every single kid in your class, then that would be population data. But if you're using the kids in your class to represent the whole school, that's only a sample. Okay? Finally, to finish up exercise 5, which of the following data sets would have a standard deviation that's closest to 0? Do it without your calculator. So for a question like this, you just want to see which one of these hardly varies at all from the other points, right? These points all vary. These points all vary. These points all vary. These points are all pretty close to the same, 11, 11, 12, 13, 13, right? So even though choice 4 also has very close to little deviation from the mean, the fact that the 3 and the 18 are there mess it all up. If it was just 7, 11, 11, 11, it'd be different, but the 3 and the 18 mess it up. So choice 3 would be the best, okay? Because our mean is going to be somewhere around 12 and 11 and 13 both hardly vary from that, okay? And that's it, all right? So hopefully you were able to watch this video and learn how to do this in the calculator, as it will be helpful in the future. Okay, guys, have fun.